Welcome back everyone. In this video we're going to discuss pair of linear equations in two variables. Here we'll be discussing how to solve the two equations using graphical method. So without any further ado, let's get started. The name linear equations means the power of the equations will be 1. That is, the degree of the equations will be 1. In two variables means you'll have two distinct variable. Okay, it may be x, y, p, q, s, t and so on, and it'll be in the pair form. That is, you'll have two variables. We know that linear equations in two variables are of form ax plus by plus c equals to 0. Okay, and the other one will also be ax plus by plus c is equal to 0. But since we cannot have two a's, so we'll just write a1, b1, c1, a2, b2 and c2. This is an example of linear equation in two variable. You see the variables are x, y, even here it is x and y. Okay, so it is x plus 2y plus 5 equals to 0 and 2x minus 3y minus 23 equals to 0. So if you compare this with the general equation, we get a1 to be 1, b1 to be 2 and c1 to be 5. Whereas for this one, a2 will be 2, b2 will be minus 3. Okay, even this minus will come into picture, and c2 will simply be minus 23. Let's see one more example. So this is linear equation in two variable x and y. So we have 4x minus y is equal to 5. Now from here we cannot say which one is a1, b1 and c1 because it is not in the general form. So let us bring this in the general form. So it will be in the general form if we bring this 5 here. Okay, so it will be 4x minus y and this plus 5, so plus 5 becomes minus 5. So from here if you compare with the general equation, you get a1 to be 4, b1 to be minus 1 and c1 to be simply minus 5. Now if you plot any pair of linear equations in two variables, you might end up with three situations. This is the first situation, second situation and the third situation. In the first situation, these two lines may intersect at a point. Okay, and this point of intersection is known as your solution. Okay, so where it is intersecting is called your solution. It may be parallel. Okay, these two lines may be parallel and it may be coinciding, that is, one line is on top of the other line. Okay, so we can say that this is solution, we can also say this is solution, this is solution, this is solution, this is solution. Okay, actually any point on the line can be treated as a solution, whereas here there is no point of intersection, so we can say that no solution. Okay, so here there is only one point, so we can say it is unique solution, no solution and infinitely many solutions. Okay, so what will be the formula to find out whether it is unique, no solution or infinitely many solution? For that we will divide a1 by a2 and b1 by b2 and c1 by c2. Okay, if a1 by a2 is not equal to b1 by b2, then it is definitely this. Okay, it cannot be this, it cannot be this. If a1 by a2 is equal to b1 by b2, okay, a1 by a2 equals to b1 by b2, so it may be either no solution or infinitely many solution. So we will also find c1 by c2. c1 by c2, if it is equal to a1 by b2 and b1 by b2, then it is definitely infinitely many solution, and if it is not equal, it is definitely parallel. This method is known as graphical method. We will have some other methods such as substitution method, elimination method, cross multiplication method. These three methods we'll be looking in the upcoming videos. In this video we'll be discussing only the graphical method. So let us see some numericals. Let us see the question shown on the screen. Determine whether the lines representing the following pairs of linear equations intersect at a point, or parallel, or coincident. So this is the question. So the given pair of linear equation is this and this. So we see that it is already in the general form, that is ax plus by plus c is equal to 0. So we don't need to manipulate it. So from here we know that a1 is 5, b1 is minus 4 and c1 is 8. a1, b1, c1. Similarly a2, b2, c2. So A2 is 7, B2 is 6, and C2 is -9. Now in order to find out whether it is intersecting, parallel or coincident, we know that we have to find A1 A2, B1 B2 and C1 C2 in some situations, right? So A1 by E2 is 5 by 7, B1 by B2 is -4 by 6. So we see that they are not equal. Okay, so actually we don't have to find C1 by C2, we can just stop here. Fine, so A1 by A2 is not equal to B1 by B2, and this condition was for intersecting. Hence the line represented by 1 and 2 intersect at a point. Let us see the second pair. The given pair of linear equation is this and this. Again, this is already in the general form, that is ax plus by plus c is equal to 0. So from here if you compare, you get a1, b1, c1. a1 is 9, b1 is 3, c1 is 12, a2, b2, c2. a2 is 18, b2 is 6 and c2 is 24. So we'll find a1 by a2, which is 9 by 18, which is half. b1 by b2, which is 3 by 6, which is half. So we see that a1 by a2 is equal to b1 by b2. So we'll have to find c1 by c2 also. c1 by c2 is 12 by 24, which is half. So we see that a1 by a2 equals to b1 by b2 is equal to c1 by c2, where all of them are half. Hence the line represented by 1 and 2 are coincident. Okay, that is on top of one another. Let us do the second type of question. Find out whether the following system of linear equations are consistent or inconsistent. Now, consistent means the solution is unique, that is intersecting, or infinitely many, that is coincident, and inconsistent means it is parallel. Okay, that is the lines are parallel. So let us see the first question. The given system of linear equation is 3x plus 5y minus 6. Again, it is in the standard form or the general form. So here a1 is equal to this, b1 c1, a2 b2 c2, which is this. So we'll find a1 by a2 and b1 by b2 first. We see that a1 by a2 is not equal to b1 by b2, so again we don't need to find c1 by c2. So we can directly say that a1 by a2 is not equal to b1 by b2. Therefore the system has unique solution. Now unique solution means consistent. Hence the given system of linear equation is consistent. Let's see one more question. For what value of k will the following system of linear equations have infinitely many solutions? That is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is the condition for having infinitely many solutions. So this is the equation. Now we see that this is not in the general form. Alright, it is ax plus by and c is in this side. Even for this, c is this side. Now c means constant, that is without x and y. So we can bring this whole thing here and bring this whole thing here. Okay, so k will come here as minus k, and k minus 3 will come out as minus k minus 3 and under the bracket. So from here if you compare it with the general equation, you get a1 b1 c1, a2 b2 c2 from here. Alright, for infinitely many solution, this is the condition. Now if you can substitute a1 a2 b1 b2 and so on, you get this. Okay, what we will do is we will be dividing this into two equations, that is this will be the first one and this will be the second one. Now if you solve this first one, k will go here, so it will become k square. 12 into 3 is 36, so we'll get k is equal to square root of 36, which is plus minus 6. So it may be either plus 6 or minus 6. Then from the last two, that is this, if you solve, k will go here, so you'll get minus 3k, and k will go here, so you'll get k into minus 3, and with a minus sign, minus minus will get cancelled. Okay, then k into k is k square minus 3k, then this 3k will come here, it will become 6k. They've skipped many steps. This is actually 3k is equal to k square minus 3k. Alright, then 3k can come here, so you'll get k square minus 6k. Then you can take k common again, so you'll get k minus 6 is equal to 0. Now either k is 0 or k minus 6 is equal to 0. So we get either k is 0 or k is 6. Okay, so from here we get k is 0 or 6, and from here we get k is plus 6 or minus 6. We see that plus 6 is common for these two, so we will take k to be minus 6 since it is common value from 3 and 4. Let us see one question shown on the screen. Find the values of k for which the system of equation this has number 1 unique solution, number 2 no solution, number 3 the value of k doesn't exist for which the system has infinitely many solutions. Okay, so this question is like a general question where all the three types have been given. So let's try to solve this. The given system of equation is this and this. Now it is already in the general form, so we don't need to bring it in the general form. Here a1 is this, b1 is this, c1 is this, a2, b2, c2 is this. Okay, by now I'm sure you know how to find a1, b1 and so on. So the first one is for unique solution. Now for unique solution we know that a1 by a2 is not equal to b1 by b2. So k by 6 is not equal to minus 1 by 2, k by 6 is not equal to 1 by 2, and if you solve this you'll get k is not equal to 3. Hence k can have any value except 3. Okay, that is k can be 1, 2, not 3, 4, 5 and also negative numbers and so on. All the values except 3. For no solution, a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. So from here we get k to be 3, and from the last two we have k has no value because here we don't have k, right, in this two, so we cannot find the value of k. So from 3 and 4 we can say that k is equal to 3. For infinitely many solution, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So from here we get k to be 3. 6 will go here and divided by 2, so you'll get 3, and from here you won't get any value of k. Okay, so we can say that from the first two and the last two there is no value of k, because if you remember the previous sum we had to find what is common between the first equation and the second equation. Since there is nothing from the second equation, that means there is nothing common, so we can say that k has no value. Hence there does not exist any value of k. Let us see one very different question shown on the top of your screen. Solve the following system of equations graphically. Let's do the first one. 2x plus 3y is equal to 2 and x minus 2y is equal to 2. Okay, so we'll have to draw or solve this graphically, so we don't need a1, b1 and so on. We'll just be plotting it under the graph. So if you know how to plot this under the graph, first of all we'll have to find out the value of x from here. Okay, so it's very simple. We'll take 3y this side, then we'll take 2 at the bottom. Alright, so you get 2 minus 3y by 2. Now we'll be substituting random values of y such that we get corresponding value of x. Okay, now these values are of my choice. This value can be anything. So the first value that I've taken for y is 0. Then if you substitute 0 here, then 3 zeros are 0, 2 minus 0 is 2, and 2 divided by 2 is 1. So y is 0, x is 1, so your coordinate becomes 1 comma 0. Similarly, if y is 2, then this will be 2, so 3 2s are 6, 2 minus 6 is minus 4, minus 4 by 2 is minus 2. So x is minus 2 and y is 2, so the coordinate becomes this, and similarly here also. Then for the second one, it is x minus 2y equals to 8. So 2y will go here, so you'll have x is equal to 8 plus 2y. So again we'll be substituting random values of y, okay, because y is on the right hand side. So let's take 0, minus 1 and 1. So if you substitute 0 here, it will become 2 into 0, 2 zeros are 0, so it becomes simply 8. If you substitute minus 1, then 2 into minus 1 is minus 2, 8 minus 2 is 6, and if you substitute 1, then 2 ones are 2, 8 plus 2 is 10. So we get this coordinate. Now if you substitute this coordinates, you will get these 3 points, alright, and if you join them you'll get a straight line which is 2x plus 3y equals to 2, and if you plot these coordinates then you will get this line, okay, joining these 3 coordinates. So we see that these two lines intersect at this point. Now this is actually our solution. Now the coordinate of this point is 4 comma minus 2, so we can say that x is equal to 4 and y is equal to minus 2. As simple as that. Let us do one more question shown on the screen. Solve the following system of equations graphically. 2x minus y is equal to 4, 3y minus x is equal to 3. Find the points where the lines meet the axis of y. Also find the area of the triangular region bounded by these lines and x-axis. So first of all, let us write down the two equations and solve it. So here we can solve like this also. 2x minus y is equal to 4. So what we can do here is we can take y here, so we'll get 2x is equal to 4 plus y, and we'll get x is equal to 4 plus y by 2. Okay, but we must try to avoid denominator so as to make the sum simple. So I see that if I try to find y, then I won't have any denominator, so I'll do that. Okay, then y will go here, 4 will go here, so it will become 2x minus 4 and y. From here I can take 2 common, so it will become 2x minus 2. Similarly here, instead of finding x, I know that I'll get a denominator 3. So instead of finding x, I'll find y. So, sorry, instead of finding y, I'll find x. So it will simply be x is equal to 3y minus 3. You can take 3 common, it becomes 3y minus 1. So again we'll be substituting x, random values of x, because x is on the right hand side, and we'll get the corresponding values of y. Okay, so first we'll substitute 2, 0 and minus 1, and after solving, this is the coordinate that you'll get. Similarly for this one, this is the coordinate that you'll get. Okay, I've already explained how do we get this in the previous sum. So plotting this point, we get 2 comma 0, so we get this line. Now this line is 2x minus y is equal to 4. We'll have to write down the equation for this line, whereas this line is 3y minus x is equal to 3. Okay, so this is the line that we get. So the question asked, where does this line intersect? So definitely we can see that the line intersect here, that is 3 comma 2. The second part was, where are they intersecting the y-axis? So we see that this line intersects the y-axis here, and this line intersects the y-axis here. The coordinate of this point is 0 comma minus 1. The coordinate of this point is 0 comma minus 4. Thirdly, we had to find area of this triangle. Now we know that area of this triangle is half into base into height. Half is known. Base means this one. So this is 1, 2, 3, 4, 5. So 5, and height means this height. Remember, height always has to be perpendicular. So this height is nothing but 2. If you solve it, you get 5 square unit. And this is how we do it. With this, we conclude our video. Link to more solutions is given in the description. So thank you for watching everyone. I hope to see you in my next video. Take care everyone.